To find the energy transferred to the 0.45 kilogram water bottle, we find the change in gravitational potential energy, and we see that the change in height of the water bottle is 1.4 meters. And from the beginning, Ren gained energy from Derek by being pushed. Now, the point that Ren hits the bottle should be a fairly elastic collision, since we see that the kinetic energy is pretty darn conserved, since Ren doesn't seem to slow down at all. This means that her change in kinetic energy should be equal to the amount of potential energy that the water bottle gets. And she hits it because she hates water bottles. Prior to hitting the bottle, the kinetic energy is 1/2 mv squared, and we know that, so we can find kinetic energy there. After hitting it, Ren's final kinetic energy is her initial kinetic energy minus the potential energy lost to the water bottle. So we can see that here. And there's a very small difference in energy, thus it does align with what we see, which is that Ren does not slow down much after the collision, since 616.8 joules is not very different from 610.5 joules. We are going to use the energy and dynamics lens to find the coefficient of friction of the bike to the concrete. Now, the force that Derek pushed with was a constant 44.5 newtons, which we measured by using a scale. Derek pushes the scale, which pushes Ren on the bike. Now, there's also the force of friction going against Derek's pushing force. We're going to look at work as change in energy here. Since work is change in energy, and we know the initial kinetic energy of Ren and bike, also the final kinetic energy of Ren and bike, we can find the work that way. And we also know that this, as the work, is equal to the work of Derek, minus the so-called work due to friction, which is really the thermal energy, because we lose some due to friction. And since we know these things, we can change the quantities around and manipulate the equation a little bit. So we get work of Dirk minus kinetic energy of Ren and bike is equal to the force of friction times distance, because force of friction times distance is the so-called-ish work due to friction. We also know that this force of friction is equal to the normal force for Ren and the bike times the coefficient of friction, which is what we're looking for here. And the normal force is mass of Ren and bike times acceleration due to gravity in this case, since there's no angle or anything. And the normal force is just however much you need to keep from falling into objects, because you can't stick your hand in an egg and expect it to not break. That doesn't happen. By substituting this into the equation, we get force of Dirk is minus kinetic energy of Ren plus bike is equal to force normal times coefficient of friction times distance. And so if you divide both sides by force normal and distance, you get coefficient of friction equal to everything else. And so with that, we can solve for the coefficient of friction. I am a duck.